what is a number? Okay, and probably the best way to handle this issue is through history. Let's start there. Numbers usually are related to amounts and quantities. And so the question is, did we invent this just 100 years ago, 1,000 years ago, maybe 2,000 years ago? How far back do we go to get to numbers, to people understanding that the notion of quantities? Is it like 100,000 years ago? How far back should we go? And here's at least some of the evidence that we have today of anything related to amounts and quantities that have been logged somehow, okay? Maybe the first numbering systems, you could call them. And here you have the Lubombo bone, okay? I think it's near South Africa or somewhere there in the southern part of Africa, somewhere in the continent, right? That's one bone. It's got some marks in it, some people think it's got to do with the moon cycles, other with female menstruation and so on, so we don't really know. You can only guess and theorize. Wolf bone, something similar, marks on a bone, and the Ashango bone also with marks. So all these are examples that maybe are way back forefathers. They probably marked some of these things for whatever reasons, and it looks like they already had that these marks had something to do with counting. Closer to our days, about 2,500 years before Christ, we're talking about maybe 4 or 5,000, 6,000 years ago, they had the abacus, okay, and that's a counting device, right? There's the Salmus tablet. They dated it to about 300 BC, and again, it's like abacus on a scroll or papyrus or something. And then in the Americas, we had this quipu, which is a device that has knots. And these people, especially the elites, the people who were going to be the professors, the teachers, the doctors, they knew how to handle this. They had these knots, and they could count with these knots. It's a type of abacus also, but it's made with these ropes. Okay, and so we learned how to count. We learned about amounts and quantities a long time ago. Okay, now numbers they came later. But then the question is, how did they handle these things? If numbers came later, how was this handled originally? And here you have one way, that you can relate to this is through trade, okay? Because people did begin to trade at some point in the Neolithic, and if you gave him a cow, what did he give you in exchange? Well, maybe he gave you barley, I don't know, but what if you had this common coin that everybody accepted, right? And then at that point you would say, okay, just give me so many coins for the cow or for whatever you gave him, and you could do something with those coins. And that had to give you also an idea of amounts and quantities, okay? Because you wouldn't sell the cow for just 2 grains of corn. You had to ask for something else. And so here's the notion we have today that, or at least this is the evidence, the hard evidence, okay? We have coins it says there, the shekel from Mesopotamia, okay? And the first known form of currency emerged nearly 5,000 years ago, some kind of currency. We don't really know what, but the earliest known mints, okay, the actual coin, right? They date to about 600, 650 BC, Asia Minor in Lydia, and here you had the main guy who we got those from, Croesus, and there you have him swimming in gold. He was known to be very rich. Okay, he had these troops and everything. He fought against the Persians and lost, and Cyrus the Great, took him as a prisoner. There's 2 versions of that. They say that Cyrus named him as his right-hand man or put him as a governor. And the other version is that he burned him alive. I tend to like the second version. I think that's what he probably did. Okay, but anyways, this is when coins started out. Okay, at least solid evidence. We do have these coins in our hands today. Okay, but that was 600 years before BC, right, before Christ. But here you have King Midas, and he's known as the guy with the golden touch, right? He had the Midas touch, and he touched his daughter and turned her into gold. And they say he lived around 2000 BC. Okay, now the reason for that is that the Midas touch, right, is that he was a very rich guy, apparently, or at least that's what the mythology says, right? Uh, Apparently, there was some king 2,000 years, or at least 1,400 years before Croesus, right? That already had lots of money. Now, did he have gold coins? Is the question, and the answer is probably not. But then, how did they handle these things? What was the amount? Did they have a pile of sand, and they say, okay, we'll weigh it against your pile of gold nuggets or whatever? This was the issue. How did they do or silver, right, for that matter? How did they do these transactions? And obviously, they gave silver less value than gold, which means that they understood the difference or the commonality of how much gold there was versus how much silver, I guess, right? But we have a specific piece of evidence, okay, and here it is, and it's the Code of Hammurabi, and that dates to almost 2,000 years ago, about the time of King Midas, a little later, but more or less. And we have the code, okay, we have the code today. It's about 280 plus 288 lines, I think it is, of how people should behave or else, right? And you can see there, they talk about money, silver, gold, money, shekel. And the question, what were these? Were they coins? We don't have any evidence that they had coins, but then they had to have some piece that was like standard, because when you talk about the shekel, I guess you're talking about some unit of some kind, right? But we don't have these. Apparently, we don't have them today. I haven't found it, but maybe it is somewhere. They have the late shekels. The Hebrews, they had shekels as well. Okay, but those came after. They came like 600 years before Christ, which is about the time of Lydia's Croesus coins. We know that there were coins 600, maybe even 700 years before Christ. But the question is, were there coins, minted coins, 2,000 years before Christ? That's the issue. Okay, but all this points to the fact that we had a notion of amounts, and we needed those notions in order to make commercial transactions, trade, right? So we were aware of that, but then that's got to have some kind of numbering system behind it. How do you have amounts without having some kind of notion of numbers, okay, of quantities, okay? So I don't know how they handled it then. Maybe a little making some marks with unclayed tablets. Say, look, three of these, that's 4 of yours, or whatever. Or these 3 represent 1 cow, or whatever it was, But yeah, that's, I guess, the first notions we had of that. Okay, so what is the discipline that deals with numbers? Well, it's known as mathematics. Okay, mathematics is an area of knowledge that includes the topics of what? Numbers. Okay, mathematics deals with numbers. It's not chemistry specifically, right? It's not literature. It's not art. No, it's known as mathematics. Formulas and related structures, shapes, and the spaces in which they are contained. Well, I'll disagree that, because mathematics does not deal with shapes at all. Okay, they deal with quantities, not with shapes, and quantities and their changes. Okay, there is no general consensus among mathematicians about a common definition for their academic discipline. So here we have all these mathematicians. Okay. And they say, I'm a mathematician. Oh, okay, what do you do? Oh, I don't know, because we never defined our discipline. Okay, in a branch of mathematics, which is probably where we should start, because We're talking about amounts at the basic level, at the numbers, right? When we created numbers, okay? And it looks like this. It says, what is arithmetic? That's what it's about, right? Arithmetic is this tiny branch, I guess you could say, or the beginning branch, okay? And it says arithmetic is the branch of math, right, that deals with the study of numbers. Okay, so that's where we start, arithmetic, using various operations on them. Okay, so operations are separate from numbers. Okay, and it says basic operations of math are addition, subtraction, and so on. Right. Okay, so we're all familiar with that. Okay, so we're talking about arithmetic. When we're dealing with numbers, primarily we're talking about arithmetic. Okay, so here's a discipline that within math that deals with numbers. We call it arithmetic. Okay, but then what is a number? What do we mean when we say number? What is a number? And so this is a definition you'll find in the Wikipedia, and it's the perfect super duper scientific definition of the word number. So please pay attention. A number is a mathematical object. Used to what? Count, measure, and label. Okay, especially keep an eye on the words count and measure. Okay, that's what they're going to use, this mathematical object, whatever that is, right? So what is a mathematical object? All this is from the Wikipedia, so you'll find it in there. It's an abstract concept. An object is a concept. Okay, includes numbers. Great. I mean, so we have a number is a mathematical object, which is a number. Great. We have a circular definition known as a synonym, right? Abstract concept. What is abstract? Well, abstraction, conceptual process. I like that. So we have a concept. That's what it is. A conceptual concept. That's what an abstract concept is. It's a conceptual process, right? What is a concept? It's an abstract idea. I like that. Concept is an abstract. Abstract is a concept, and concept is an abstract. Absolutely love that. Abstract idea. What's an idea? Well, the result of thought. Okay. Yeah, I hope you're following. I hope you can take the test on Friday. Okay. What is thought? Conscious process. And what is consciousness? Awareness of existence. I hope you now know what a number is. Okay. And I like the fact that the only part that's probably true is just a definitional issue, right? Numbers should be distinguished from numerals. Okay, numerals are different than numbers. Okay, numeral is the little symbol that we use to represent the number, and it could be a letter. You know, like letter A, that represents a number or a variable or whatever, right? And the symbols used to represent numbers. Okay, so I hope you know what a number is now. Okay. Okay, so what's the issue? The issue is that they want to focus, the mathematicians, don't want to just stay with counting. They want to also go into measuring. And there's a difference between counting and measuring. Counting, you count units. Okay, measure, you can have fractions, decimals and so on. So measuring is a little different than counting, right? It's not the same activity, okay? And so here you have the question is a number an issue of counting or is it an issue of measuring? Okay, are we counting units or are we measuring something that goes beyond the unit or halfway between two units? Okay, so we have a difference. If number refers to counting, then it ain't measuring, and vice versa. We need to define that word number correctly, and we have to find out if it's counting or measuring. And what they did is they put everything in there. They said it's counting, it's measuring, it's labeling, the whole thing. And this creates a little bit of problem, right? Because when you cover every base, you lose information. You don't gain information, you lose it. Because you put it all in there and people get confused. Is it about measuring? Is it about counting? Okay. And so what are we going to argue here? Well, we're going to say that it's only counting. It's got nothing at all to do with measuring. Okay. So here's counting. Okay. What is number? It's a verb. It's not a noun. It's a verb. It's a verb to count. Okay. What are you doing? You're moving the finger up and down, right? 1, 2, 3, and what you're doing is increasingly, giving a new label to the new amount, to the new quantity. Okay, so that's how you're doing. So number is the verb to count. That's what the word number stands for, and we depict it or illustrate it with a symbol called a numeral. Okay, so that's what we argue here. But if it's counting, it ain't measuring, because counting and measuring are two different activities. And the problem we have with the mathematicians is that they want to include measuring. Okay, and so here's an example. The complex number system says is an element of a number system that extends the real numbers with a specific element denoted, etc., etc. The irrational numbers called imaginary numbers unit and satisfying the equation, etc., etc. Okay, and so they have all these examples there of what an imaginary number is. And the question is are these numbers? What are these numbers used for? And I'm saying that these numbers are used for measuring. It's got to do with measurement, not at all with counting. You cannot count to 1 1/3. Okay? You cannot count to 3/5 or whatever, okay? Whatever fraction. And you can also put that in terms of fractions. I'm sorry, in terms of decimals, okay? Because a decimal point is just that. And so here's the problem that I see with that. See, the mathematicians merge numerals with operations and call them numbers because they have the numeral, okay? In this case, there's an example there, okay? 2/3 or 1 and 1.35, okay? And the question, what are we staring at? Well, the number is 2. The 2 is a numeral that represents the number 2, which is the quantities that you counted. Okay, you counted twice, and you call that a 2. You put a numeral that looks like that symbol there, 2, and you did the same thing with a 3, but now you're going to perform an operation, 2 over 3. You're going to divide 2 into 3, and the question is that operation that you did with these two numerals, with these two quantities, with these two numbers, right? Is that a number? Okay, and the mathematicians say, yes, it is. But for that, you have to define the word number correctly so that it fits, so that it includes the operation. Okay, and so what they did, they bunched it all together and they say, well, it's all the same, numbers, operations, transactions that you do between numbers, that's also a number, because the result is some kind of, could be a fraction, right? You have 1 over 1, you get 1, right? But 2 over 2, you get 1 also, right? But if you have a fraction, like 2/3 or, I don't know, 1/5 or whatever, well, then you'll get the fraction on the one hand, you can turn that into a decimal, which is a different way of writing the fraction, okay? And the issue is that we can't count to a fraction. We can only count units. And so you can see the difference between counting and measuring, because measurement almost always has to do with fractions and decimals, whereas counting is always units. Okay, you could say the integers, right? And so here's my criticism. Fraction is an operation. Okay, 2 and 3 are the numerals in the example above, right? And the and the slash is what you do to them. That's an operation you're going to perform on these two numbers, right? 0.35, again, that's a different way of presenting a fraction, any fraction. So we can only count integers, right? And we can't count to 0. So 0 is not a number because you can't count 0 again, like I'm saying, 0 cows, 0 trees, and 0 apples is all the same. Okay, it's like we don't care about the unit. It's like it's 0, whatever. So you can't say that 0 is a number. 0 is the absence of numbers, of things to count. Okay, so 0, we're not going to include it as a number, okay, under our definition, which is counting. Can't count to 0, and you can't count to infinity. How long are you going to live? You're going to continue counting, and then when you die, the numbers continue. It's like you can't count to infinity, because infinity just means you count forever until the universe expires or whatever. So no, you got to keep these things in mind that the definitions are important. And what the mathematicians never did is define. Okay? They're terrible definers. Okay? They don't know how to define words scientifically, and that's why they get involved in problems afterwards because they run against brick walls. They can say whatever they want because they're using words of ordinary speech rather than words which are scientifically defined. Okay, so here we have another version, another issue with numbers are negative numbers. And here we have, negative is the same thing as positive in a sense because both involve an operation. Positive are not integers. See, many people confuse them because they say, well, you don't need to put the plus sign if it's a positive integer. And so they confuse integers, with operations, which is the plus sign. And likewise, they think that negative is also a number because they have this little, this one or the two after the negative sign. But see, negative and positive are operations. Integers are just the numbers, that little numeral that represents a number. Okay, so a little different. That's why it's important to keep these things separate so that we understand them well. Negative, again, is a subtraction operation. It's like division, square root, power, etc. Number stands alone without an operation. Okay? It's the numeral representing the number. The number is counting. Okay? That's what number is. Number is a symbol. Number is to count. Okay? So, under my definition, where do we put the word number in our universal movie? Universal movie has the distinction between dynamic and static concepts. Static concepts only take up one frame in the universal movie, whereas dynamic concepts take up a minimum of two, and usually more. In other words, dynamic concepts are those that embody motion, whereas static concepts are those that do not have motion. They embody only location, okay? Distance between objects. We're talking about physics, right? So it's either a static concept fits in a single frame of the universal movie, or it involves two or more frames. Where are we going to put number? Well, it's the verb to count. Where do you think we're going to put it? We're going to put it at the bottom. We're going to put it in the dynamic concept region, because it's the verb to count. Number requires at least two frames of the movie. You're making a comparison also between numbers. I mean, if there was only one number in the world, one, right, for example, then it might even have a chance to go in the static concept region, the upper part, single frame. But number is, you don't only have one number, you have many numbers. So number is a comparison against other numbers. That's one issue. And the other one is that you need to move that finger up and down to count. That's what number is. So yeah, number is a dynamic concept. It's not a static concept at all. Okay. And so here we go with our conclusions. Okay, we have number is a dynamic concept. Okay, number is the verb to count. And hopefully counting is a dynamic activity, a verb. We can't count to zero, okay, because there's nothing to count, literally. Can't count to infinity, okay, because you won't live that long. Fraction is an operation, okay, and that's what it's got to do with measurement, okay. Negative numbers, again, also an operation. And a numeral is not the same thing as number, because the numeral is the symbol you're going to use to represent counting. Okay. What is our corollary? Well, we have mathematical physics. The physicists out there, they don't do arithmetic. Reading, writing, arithmetic, the 3 R's, okay? They don't work with integers, almost at all, rarely. No, they do measurements because they do experiments, and then they do operations, okay? They have equations, right? They use decimals and fractions, okay? So the reason mathematical physicists like the definition that they have today, where they put everything in there, They say numbers everything. It includes the operation. It includes zero. It includes infinity. It includes all these things in there. Some of them don't. They say zero and infinity are not. Others say yes. So they have these debates. And again, because they don't define what a number is. Because if they defined it as counting, you can't count to zero and you can't count to infinity. So those two are taken off, okay, off the record. No, you can only count integers, so that eliminates negative signs, fractions, etc. And so, yeah, it's the mathematical physicists with quotations, right? Those are the ones who want to include the word measurement in there, meaning fractions. Why? Because they want to do operations and they want to include the word number together with an operation and call that whole thing a number, which is actually a result of an operation. Okay? Because what is 2/3? 2/3 is a fraction, a decimal if you're going to use 0.66, etc. But the point here is that if you're going to use 2/3, what you're looking at is the result of that operation. So we instantly say, what is 2/3? Well, it's 0.66, right? Or 2/3, you know it's not a unit. It's 2/3 is a fraction of a unit. And why? Because you already performed an operation. What you did is you cut the table by 1/3. You say, I have 2/3 of a table, 2/3 of a tree or whatever, right? 2/3 of a rock. So you performed an operation, and 2/3 is an operation. Okay? So they're looking at the result, and that's what they do in mathematical physics. They carry out experiments out there, measurements, observations, whatever they call them, predictions, and they represent their calculations in the form of decimals usually. You know, rarely, very rarely do you get to an integer today. That's why, you know, mathematical physics is outside the bounds of arithmetic, which deals primarily or exclusively, with integers. Whereas mathematics includes the whole shebang. You know, they do operations. They put everything and they call them numbers. Okay, and what is a number? According to them, it's a mathematical object, which is a concept, which is an abstraction, which is a concept, which is an abstraction. It goes all in a circular way, and so you never find out what they're talking about. That's why they can't define what mathematics is about.